Google Cloud, cloud infrastructure built on Google's network. Agenda, cloud computing models, GCP history, why GCP, GCP resource lifecycle, getting started, basic workflow, compute and storage. Cloud computing. Cloud computing gives you on-demand access to compute, storage, and networking. Built for exactly what you consume. If usage grows unexpectedly, you can add capacity in seconds instead of waiting on new hardware. Almost every modern engineering team relies on a public cloud for at least part of its stack. Any company that needs to move fast benefits from infrastructure it doesn't have to build itself. Building and running your own data center for every new product doesn't scale. On-premises and cloud systems. An on-premises system runs on hardware your own team buys, installs, and maintains for years. A cloud platform like Google Cloud rents compute and storage running on Google's own global infrastructure. On-premises, your own server room, self-managed hardware, fixed upfront capacity. Cloud, Google Cloud, AWS, Microsoft Azure. Problems with on-premises infrastructure. Single point of failure. One facility outage can take critical systems offline. Large upfront capital cost for hardware that's often oversized for average demand. Slow to scale. New capacity can take weeks to order, ship, and install. Hard to reach users worldwide with consistently low latency. Every patch, backup, and hardware refresh is your team's responsibility alone. Misses out on managed services that remove entire categories of operational work. GCP Cloud Platform System infrastructure is declared in Terraform or deployment manager templates and kept in a source or Git repository. Every resource lives inside a project, which is itself grouped under an organization. Google Cloud's control plane reconciles what's running against what you have declared, project by project. Other similar cloud platforms: AWS, Microsoft Azure, IBM Cloud, Oracle Cloud, on-premise cloud. GCP advantages: runs on the same global network and infrastructure that powers Google Search and YouTube. Speeds up delivery with managed services like BigQuery, Cloud Run, and Cloud SQL. Live migration moves running virtual machines off failing hardware with no downtime. Makes container workloads simple with GKE. The platform Kubernetes was born on. Strong data analytics and AI ML tooling backed by Google's own research. Sustained use discounts reduce cost automatically the longer a VM runs. Everything is a project, almost. One huge benefit is that in Google Cloud, almost everything you create belongs to a project. Billing, IAM, permissions, and quotas are all scoped cleanly at the project level. Labels let you tag resources for cost tracking and automation, just like folders for your infrastructure. Cloud audit logs record every API call, so you always know who changed what. Deleting a project cleanly shuts down and removes everything created inside it. Projects and IAM. Projects, the container that holds billing, IAM, and every resource you create. IAM grants a specific role to a specific member on a project or a resource. Main.tf. A Terraform resource declares a compute engine VM and its properties in the version controlled file. Deploying with gcloud. Here the gcloud CLI creates a cloud storage bucket and confirms the resulting resources. History began in 2008 with a limited preview of App Engine, Google's first public cloud service. Compute Engine, a more traditional virtual machine offering, reached a general availability in 2013. Unified under the Google Cloud Platform name as more products launched throughout the 2010s. Google Kubernetes Engine launched in 2015, drawing directly on Google's internal box system. Now a major global cloud provider, especially strong in data analytics, AI, and Kubernetes-based workloads. Why GCP? Global network. Traffic often rides Google's own private backbone, not the public internet. Live migration, maintenance, and hardware failures rarely cause VM downtime. Data and AI strength, BigQuery, Vertex AI, and decades of Google research. Kubernetes native, GKE is run by the same team that created Kubernetes. Simple pricing, automatic sustained use, and committed use discounts. Backed by Google's long-term investment in global infrastructure. The gcloud configuration. gcloud stores its active project, account, and region in a local configuration under .config gcloud within the user's home folder. Application default credentials let SDKs authenticate the same way the CLI does. Multiple Lambda configurations let you switch between projects or accounts instantly. Never commit service account key files to Git. Prefer short-lived credentials instead. GCP resource lifecycle. Project create, provision, Terraform apply, deploy, cloud monitoring, monitor, instances delete. Resources are provisioned inside a project, deployed from the template, monitored for health and cost, and deleted when no longer needed. Getting started with GCP. This leads us to the three commands that get a project running in the cloud. gcloud init. Sign in and select your active project. gcloud config list. Confirm the project and account the CLI will use. gcloud compute instances create. Launch your first virtual machine. Basic workflow. Create a resource, define a resource, create a resource, apply a resource, monitor resource, optimize a resource. Provisioning, deploying, and monitoring. Some call provision, deploy, and monitor GCP's everyday loop. Declarative. Reapply the same Terraform config and GCP only changes what's different. gcloud compute instances list gives an instant snapshot of what's running. Scaling a service is one command away with no manual hardware involved. Cloud monitoring and alerting catch problems before customers notice them. Supports many workflows, VMs, GKE clusters, serverless functions, data pipelines. Works the same across every region Google Cloud operates in. Any question? Thank you.